गुड मॉर्निंग बच्चों। आज हमने कोऑर्डिनेशन कंपाउंड्स का एक टॉपिक लिया है जिसमें हम वैलेंस बॉन्ड थ्योरी के बेस पे वी विल फाइंड आउट द स्पिन ओनली मैग्नेटिक मोमेंट, हाइब्रिडाइजेशन एंड ज्योमेट्री ऑफ वेरियस कोऑर्डिनेशन कंपाउंड्स। इसमें हम ये 4 एग्जांपल्स लेंगे। पहले 2 एग्जांपल्स जिनमें कोऑर्डिनेशन नंबर 4 है और दूसरे जिनमें कोऑर्डिनेशन नंबर 6 है। और इसमें जो क्लोराइड है दैट इज ए वीक फील्ड लिगेंड और जो साइनाइड -N है दैट इज ए स्ट्रॉन्ग फील्ड लिगेंड। हियर दिस फ्लोराइड ion is a weak field ligand and this ammonia is on the border, that is but it acts as a strong field ligand in case of cobalt is present in the higher oxidation state of +3। तो ये 4 एग्जांपल लेके we will make this procedure elaborated। So let us first take the example of NiCl4 2-. So we write NiCl4 2-. First we will write the electronic configuration of nickel, that is nickel is atomic number is 28. So this will be argon 18, remaining 10 electrons, so it will be 4s2 and 3d8. Okay, now what is the oxidation state of nickel in this compound? So we can determine, say x -4 equal to -2, so x equal to +2. So nickel is present in +2 oxidation state, so I will write the configuration of nickel 2+, so that will be 3d8. Okay, now I will write 3d8. There are 5 orbitals in D, so 1 electron each, then total 3 more electrons, so this is the 3d8. Okay, now there are 4 ligands which have to make the 4 numbers of coordinate bonds with this nickel 2+ ion, so it needs 4 numbers of empty orbitals. Okay, and this nickel has, this is 3d, then there will be 4s, let us say this is 4s, and there are 3 empty orbitals of 4p, so this is 4s and this is 4p, they are empty orbitals. Now these ligands can utilize these empty orbitals for the coordinate bond. So as per the valence bond theory, these 1s and 3p orbital, they will get hybridized with sp3 hybridization and will make 4 numbers of sp3 hybridized orbitals. Okay, so these are the sp3 hybridized orbitals, 4 empty orbitals. Now these 4 ligands, that is chloride, each will donate 1 electron pair to these empty hybrid orbitals, so 2 electrons they will donate here. Okay, because chloride is a weak ligand, so electron pairing it cannot cause, so there is no electron pairing done and only the vacant orbitals available have been utilized for hybridization. Okay, so we can say that this is the hybridization is sp3. So what will be the geometry? Geometry will be tetrahedral. Okay, and there are two numbers of unpaired electrons. So spin only magnetic moment mu s equal to under root n into n plus 2, this much Bohr magneton. So here n is equal to 2, that is the number of unpaired electrons. So we can find the Bohr magnetic moment. This is spin only magnetic moment is equal to under root 2 into 2 plus 2, that is nothing but 2 under root 2, that is 2 into 1.414, that is 2.828, this much Bohr magneton. So that is how we can find out the value of spin only magnetic moment and the geometry based on the hybridization. Okay, now let us take the second example of NiCN4 2 minus, where Cn minus is a strong field ligand which can result in pairing up of electrons. So let us write NiCN4 2 minus. Again we will write the electronic configuration of nickel, that is argon 18 3d8 4s2. Okay, now what is the oxidation state of nickel? X minus 4 equal to minus 2, X equal to plus 2. So nickel is present in plus 2 oxidation state. So I will write the configuration of nickel 2 plus, which will be these 4s2 electrons will be lost. So it will have 3d8. Okay, again I will write 3d8 can be represented as 5 orbitals of 3d. So 1 electron each, remaining 3 electrons. Okay, so this is the nickel 2 plus. Now this Cn minus is a strong field ligand. Okay, so it will, this electrons pairing will, it will result in the pairing up of electrons. Okay, so this one electron will get paired up here, and I have one empty orbital of (3d) that will be available here, and the nearby we have one 4s. So this is 3d. Okay, and there will be 3 empty orbitals of p. So this is 4p. Okay, now there are 4 ligands, so they need 4 empty orbitals. Okay, so 1d, this d is 1, 2, 3, 4. So these 4 orbitals will do the hybridization, that is dsp2. So hybridization will be dsp2, because 1 empty orbital of d, 1 s and 2 p orbitals. So dsp2 hybridization will be there. The geometry will be square planar, and there are no unpaired electrons, so spin only magnetic moment will be 0. And how we can represent this? So this we will represent like this. So this is our 3D. Okay, and we will have 4 hybrid orbitals of dsp2 hybridized orbitals, 1, 2, 3, 4. Okay, now the Cn minus, there are 6 ligands, so each ligand will donate 1 pair of electron to these empty hybrid orbitals, that is dsp2 hybrid orbitals, and the geometry will be square planar, and the angular momentum µs will be 0 as number of unpaired electrons is 0 here, and the geometry will look like this. I will just draw the geometry, how it will look. That is the square planar, so it will be like this: nickel, Cn, Cn, Cn and Cn. Okay, so that is like this, and this whole will have 2 minus. Okay, that is the square planar geometry of NiCN4 2 minus. Now we take the examples, 2 more examples for the compounds having coordination number of 4. So let us take first COF6. Okay, that is 3 minus, and we know that fluoride is also a weak field ligand and cobalt 27. So first we will write the electronic configuration of cobalt 27, that is argon 18, remaining 9 electrons, so 4s2 3d7. Okay, now what is the oxidation state of cobalt here? X minus 6 equal to minus 3, so x equal to plus 3. So I will write the configuration for cobalt 3 plus ion, that will be 3d6. Okay, now I will represent 3d6 like this: 1, 2, 3, 4, 5. 1 electron each and 1 electron here. Okay, now because fluoride is a weak field ligand, so no pairing of electron will take place. So this is the 3d6, and here I have one 4s empty orbital and 4p orbital. There are 3 4p orbitals, but we require 6 empty orbitals, so it will also utilize the empty orbitals of 4d. There are 5 empty orbitals available. Okay, now for making 6 coordinate bonds, we need 6 hybrid orbitals which are empty. So 1, 2, 3, 4, 5, 6. So this hybridization will take place, that is 1s, 3p and 2d orbitals will get hybridized, and the hybridization will be called sp3d2. Okay, and because we have used the outer orbital of 4d instead of the 3d for hybridization, so this is called the outer orbital complex. Okay, because we have utilized the outer, that is the 4d orbital for hybridization. So how it will look like this? There will be 6 hybrid orbitals of sp3d2. So they will look like this: 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5, 6 sp3d2 hybridized orbitals, and there are 6 ligands: F, 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 and they will donate this 1 electron pair to each empty orbital, that is the hybrid orbital. Okay, and 2 electrons, that is 1 pair of electrons, will be donated by each ligand. Okay, so the geometry will be octahedral, And for spin only magnetic moment, there are 4 unpaired electrons. So number of unpaired electrons is 4. So what will be the mu s? That will be under root 4 into 4 plus 2. This much Bohr magnet. So that can be found out. And this is called the outer orbital complex because we have utilized the 4d orbitals for hybridization. If we would have utilized the 3d orbitals, empty orbitals, it would have been inner orbital complex. Now we take one more example, then we will wind up this session. And this example we have taken for the strong field ligand, that is CONS3 whole 6 3 plus. Okay, we know that ammonia is a ligand which is neither strong field nor weak field. It is on the border, but it acts as a strong field ligand in the presence of cobalt when present in higher oxidation state of +3. Here the oxidation state of cobalt is +3. So let us write the electronic configuration of cobalt, which is argon 18 and remaining 9 electrons. So 4s2 3d7. Now cobalt 3 plus will have the configuration 3d6. Okay, which can be represented as like this. There are 1 electron each and 1 more electron. So this is the 3d6. Now because ammonia acts as a strong field ligand when cobalt in the higher oxidation state of +3, so it will result in pairing up of the electrons. So these 4 electrons will get paired up and we will have here 1 electron and here 1 electron, and these will get emptied out. So this will look like this. Then this is 3d, then we have the 4s of the nearby energy and we have the 4p of nearby energy. So we need the 6 empty orbitals for coordinate bond. So we have 1, 2, 3, 4, 5, 6. So the hybridization they will do. Okay. So 2 d orbitals, 1 s and 3 p. So we will have d2sp3 hybridization, and the geometry will be octahedral, and this will somehow look like this. So there will be 6 hybrid orbitals of d2sp3, 1, 2, 3, 4, 5, 6. Okay, so and there are 6 ligands of ammonia. Each ammonia will donate 1 electron pair to each of these empty hybrid orbitals, that is d2sp3, and we see that no electron is available which is unpaired. So the number of unpaired electrons is 0. So spin only magnetic moment is 0, and the hybridization is d2sp3, and this is called the inner orbital complex because we have utilized the 3d empty orbitals for the hybridization. So it is inner orbital complex and the geometry will be octahedral. So I hope this concept is clear, how to find the magnetic moment, that is the spin only magnetic moment, hybridization, and the geometry based on the valence bond theory. Okay. with this I conclude this session and I wish you all the best. Thank you.